Class, welcome back to another exciting video from Chapter 3. We are talking about maximizing area again. We're doing something that we have seen before. This time, what I really want you to take away from here is as we maximize area here, we're more using like real-world examples, okay? I'm going to give you a real-world example. You're going to have to draw a picture, a sketch. You're going to have to figure out what's going on. There are two different types of maximizing area with fences problems. This first one is the easier of the two, where every single side of a rectangle or some shape has to be fenced. And then the next example you'll see we can sometimes use other objects as pieces of the fence, so you don't have to consider all of the sides of a shape. Alright, so let's jump into this. We have Farmer Joseph with 2,000 yards of fence to enclose a rectangular field. What are the dimensions of the rectangle that encloses the most area? Yes, the rectangle. Alright, so I'm going to start. I know I'm drawing a rectangle. Okay, I got a rectangle here, something like that. The other thing that I want you guys to know is that if we have 2,000 yards, that means that all the way around has to be 2,000. Now, it might be, I don't know. We don't know. We're trying to maximize this, so we don't know what to put for the base and the height. So what we do here is we're going to set one set of sides, as x. And why do we do that? Well, we know if one side is x, then the other side has to be x. And then we kind of reevaluate where we're at. We knew that we started with 2,000 yards of fence, and we just used 2x worth, okay? So if we think about this, we had 2,000, and we took away 2x from the original 2,000. Well, the last thing we have to do is we have to recognize that we have two sides remaining, not just one. So we actually have to divide this by 2, which is 1,000 minus x, because now we know that each of the top and the bottom have to be 1,000 minus x. And if you do a quick check here, what's x plus 1,000 minus x plus another 1,000 minus x? Well, it's 2,000. Alright, so we have a rectangle. We know some things about the dimensions. We are now ready to write an area function. Well, we know that area will be base times height. So in this case, a of x should equal, and it really doesn't matter the order, guys. Usually I guess my base is the bottom, so I'll go 1,000 minus x, and then my height is x. Something like that. Okay, now in this case, or I guess I should say in our old examples, I told you to leave it as it is. And that was because we were going to the calculator. I didn't want you to get confused at all. But if you remember correctly, this chapter is going to be all no calculator, so we do want to go ahead and distribute this. So let's see here. A of x equals 1,000x minus x squared. And then, of course, we want to write in descending order, so we're in standard form. Okay. We now have our area function. So, we move on. This is really similar to our last stuff. We need to find the domain, and we remember that because these are actual physical shapes, the base must be greater than 0, and the height must be greater than 0. I don't necessarily like writing base and height, because really your base might be x and your height might be 1,000 minus x. So I don't want you to get hung up on that. It's a side and a side. All of the sides have to be greater than 0. So, well, let's do the easy one first. Or actually, no. I use this as base. I'm going to stick with it. Okay, so 1,000 minus x has to be greater than 0. And also our height of x has to be greater than 0. Let's see here. If we solve this, you have options. I know a lot of you guys like to keep the x on the left side, so let's do it. Let's move the 1,000 over. And then when we divide by a -1, we should get x is less than 1,000. And this one's nice. We don't have to change this at all. X is greater than 0, so we combine these two ideas together. 0 is less than x is less than 1,000. We now have our domain for our graph that we are going to draw right now. So, let's see here. We should be getting really good at these by now. Let's see. Our y is a of x, just like before, and we know that that's the area. We know our x is still just x. This is where I don't want you guys to get super hung up. In my picture, my x is my height, so I am going to use height. Sorry, I was pointing at something that you guys couldn't see. In my picture, I used x as the height, so that is why in my graph, I wrote the word height. If you guys draw your picture differently, what if your 1,000 minus x were on the left and right, and your bases were x? Then I would expect you to write base for your x-axis. Again, I'm not going to get super hung up on that, because I know it's going to be different from picture to picture. What I do need is for you to understand that this is a quadratic, and there is a negative coefficient or a negative a value, so we know that this is opening down, and this is just like what we've been doing. Okay? What's really nice is we have 0, we have 1,000, we know these values from our domain. So what do we need? You guessed it. I need the vertex. This is where you guys can kind of pick and choose, okay? I think with projectile motion and maximizing area, a lot of the times H and K formulas are a little bit easier. So I'm going to go ahead and say that I need to use my H and K formulas to get my coordinates for the max height. Excuse me. Sorry, not max height, max area. So H should be negative b over 2a. And let's see here, my b value is 1,000. So negative 1,000 over 2 times negative 1. Where am I getting that from? I'm just getting that from my equation. Well, the negatives are going to cancel. And then 1,000 divided by 2, that's 500, right? So H equals 500. So 500. Now for K, C minus b squared over 4a. Well, C is 0. B is 1,000. So 1,000, 1,000, and 4 times negative 1. Let me put that in parentheses, sorry. Okay. Well, once again, negatives are going to cancel, so that's nice. This can get a little messy. It shouldn't get messy. I don't want you to make it messy. I know it's big numbers. This is doable. You guys can do this. Hopefully, we all agree that I can divide 1,000 by 4, okay? I know if I had 100 and I divided by 4, it was 25. So if I have 1,000 and I divide by 4, I'm going to be left with 250. Now the reason that we do this, and this goes back to some just basic math understanding. When you guys multiply by 1,000, you should hopefully remember that that just means you can add on or tack on 3 zeros. So my K value is the 250, but I need 3 zeros after it, so 250,000. So 250,000 is my K value. Okay, what dimensions produce the largest area? What dimensions produce the largest area? This is where I would say base, and I'd go back and I'd look, well, my base equation was 1,000 minus x. Okay, so I'm going to write it, 1,000 minus x, and I know that when I plug in 500, because that's my x value, 1,000 minus 500 is 500. And and we are in yards. My height, well, my height's real easy. My height was just x. So that's also 500 yards. So those are my two dimensions that I need. And lastly, what is the largest area? Easy, right? We have it. That's our k value. That's the y value of the vertex. The max height is 200. I keep saying height. The max area is 250,000 yards squared. Please remember this, the right units. It's square units. Okay, so really, guys, this is the same exact thing that we were doing last chapter. The only difference is I'm having you do some calculations by hand rather than with a calculator. Now, that gets, or this problem, this next example, same concepts, however, the picture is going to change a little bit. And if you remember from the beginning of the video, I said that there are going to be some times where you don't have to worry about every side of the shape. So when we read this, hopefully that makes sense. Here we go. Maine East football team is going to build a rectangular storage area for all of their equipment up against the side of the field house. Okay, up against the side of the field house. And they have 1,000 feet of fence. So let's think about this. When we draw this picture, guys, I already have a wall here. I don't have to worry about that fence, right? I need to go from here to here and back up to make my rectangle. One of the sides is completely missing, or I shouldn't say it's missing, it's just it doesn't need to be fence. So now we actually have three sides that we have to fence. Again, I usually just pick one side to set as x, and I think it's going to be way easier if we make the height here x. Now let's think about this. If this side is x, then this other side has to be x. That's just properties of a rectangle, right? They have to be congruent sides. The last thing we need to think about is, what is this last length? Well, we had 1,000 to start with, and we just used 2x worth. Now normally, or if we go back and we think about this on our other picture, I had to divide by 2. Why? Because I had two sides of fence to use this 2,000 minus 2x, so I had to divide by 2. Do I have to divide by 2 here? I do not. I do not, because I only have one side of fence remaining. So 1,000 minus 2x. All right? Now it kind of turns into the exact same thing, honestly. We have, let me keep in tradition. I know that area is going to be base times height. So when I go to my function, base times height, let's go with 1,000 minus 2x, and then my height is x. It doesn't matter the order that you write this, guys. It's going to be the exact same. Remember that because we're graphing this, we do want to distribute and turn into standard form so we can see what's going on. Which means I'm going to actually I'm going to combine a couple of steps together. I'm going to go with my largest degree first. So negative 2x times x is negative 2x squared, and then positive 1,000 times x is positive or plus 1,000x. So now I have my area function. We're ready to move on to our domain. Once again, it's a figure, it's a shape. Base has to be greater than 0, height has to be greater than 0. My base in this case was 1,000 minus 2x. My height was just x. So as I solve these, again, remember, I know you guys like to move the 1,000 over. So I have negative 2x is greater than, negative 1,000. And when I divide by negative 2, I get x has to be less than 500. Combine those two concepts together to get your total domain, or final domain. That 0 must be less than x, which must be less than 500. So we go and we draw our graph. We have a of x, we have x. Of course, this is area. Again, this is not something, you guys can't see what I'm doing, I'm so sorry. Okay, draw our graph. Make sure to label the axes correctly, right? Area along the y because that's our function name, x along the x, and again, in my case, because my picture I drew x as the height, I'm going to write height. This is not something that you have to get super hung up on, okay? But we do know that our domain is from 0 to 500, so when we draw our parabola, we know that this will be at 500, this will be at 0, and we need the maximum point, okay? So again, let's get some parentheses, figure this out. Let's use our h and k formulas again. H equals negative b over 2a. So, h equals, what's our b value? Our b value from up above was 1,000, so negative 1,000 over 2 times, a is not negative 1, it's negative 2. Alright? Well, let's think. Definitely pluses. Right? The negatives cancel, which is nice. We can cancel a 2 and a 1,000 to make 500. That's a 501. We also have this other 2, so can we keep going? Let me change colors, maybe that'll make better sense. So this is 250 and 1. So this is good. We're done. H is 250, so 250. K, same ideas. So we have c minus b squared over 4a, or 0 minus 1,000 times 1,000, 4 times negative 2. Okay. Little by little, let's take a look at what's going on. All right, first things first. This is going to be negative divided by negative. Okay, so those can go to positive. That's good. What else? 1,004. I can reduce 1,000 divided by 4. That's 251. All right. I also know that 250 is even, so boom, boom. All right, this is 125 and 1. So now we're ready to go. We have ones in the denominator, so we just have 125 times 1,000. And if you remember, 125 times 1,000 is just 125 with 3 zeros. So 125,000. All right, cool. We're getting there. We're getting there. Almost done. So dimensions. Remember how we did dimensions before. Base. My base formula was 1,000 minus 2x. If my x value is 250, I have to plug that into this equation. Well, 2 times 250 is 500, so 1,000 minus 500 is 500. And we are in feet. Please make sure to be careful on that. And let's see, height. Height's just x. And x was 250. So now I have my dimensions. Lastly, the area is just the k value, or the y value of the maximum. So 125,000 feet squared. Alright? So really, guys, same type of problems. Basically, we're still using the same concepts of quadratics, but a new type of real-world twist. Alright? I hope you guys have a great day. Have a good one.